Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. Continuation of May-June 2023 question paper. Now looking at question 8. All right, on question 8, we have what we call cubic functions. Okay, now let's just dive into it. Given f of x, it is equal to x cubed plus 4x squared minus 7x minus 10. All right, this is the equation. Now, the first one says write down the y-intercept of f. The y-intercept of f, it is equal to negative 10. Why? Because for y-intercept, you let x equal to 0. When you substitute 0 plus 0 minus 0 here, minus 10, how much do you get? You get ys as negative 10. All right? Yes, you get ys as negative 10. All right, I've answered that one. Show that x is a root of the equation f of x is equal to 0. Now, what they are trying to say now, they say to you, show us that when I substitute these two on this equation, that will result to 0. So actually, basically, they're saying show that f of 2 it is equal to 0. Okay, so how are you gonna do that? How are you gonna do that is you taking f of 2 it is equal to 2 cubed plus 4 into 2 squared minus 7 into 2 minus 10, which is 8 plus 16. 4 times 4 is 16 minus 14 minus 10. Then 8 plus this is 24 minus 24, which is equal to 0. All you need to do it is just do this. Say f of 2 it is equal to, then substitute x as 2, then it is equal to 0. Then this is your 2 marks. For saying f of 2 it is equal to and substitute, then it gives you 0. It is just your full marks. Hence factorize. Now that we see that f of 2 it is equal to 0, therefore it means that x minus 2 it is a factor. Is a factor. Why? Because when we say x minus 2 it is equal to 0, we get x it is equal to 2. It is a factor. Now, if we had f of, let's say maybe we had f of negative 2 it is equal to 0, therefore it means x plus 2 was gonna be a what? A factor. Okay, is a factor. So please take note of this sign. It is very important thereof. Now, hence, you see they say hence, so it means whatever this answer you're gonna use. Remember, I said x minus 2 is a root, right? Remember, when you factorize this one, what you need to do it is you need to find a factor, the first factor, such that when you substitute here, it gives you 0. So you're gonna go into a calculator and substitute 1, 2, 3, but now they made it easier for us and said show that 2 it is a root. So it means they have already given you a root. So how do I factorize this? Remember, when I factorize f of x, they want my what? My intercept. All right. So I'm gonna say f of x it is equal to 0. If I equate this to 0, I'm good. Or I can just actually, no, never mind. Actually, just factorize this. They did not say calculate the intercept. So just factorize this. How do I factorize this? I'm gonna say the first factor it is x minus 2, right? If your teacher teaches you a different method, please use it, okay? This is what I do. This is first term, okay? Also here it is a first term. Then I come back again and say this is my last term, negative 10, negative 2 is my last term. I'm gonna have my last term here. Then I pause a little bit. Then I say now, let's fill in. Now, what multiply by, actually x multiply by what will give us x cubed, okay? I want such that when I say this first multiply by first first multiply by first, it gives me the first from the equation. Okay, so you agree with me, this should be x squared. Okay, then I go to the last. What multiply negative 2 multiplied by what last term should give us the last term here? Okay, so negative 2 multiplied by what should give us negative 10? It is positive 5, because if I say negative 10 divided by 2 by negative 2, it gives me 5. So if you say it is negative 5 here, check negative 2 multiplied by negative 5, it is positive, and this is negative, which is wrong. All right, then I come to the middle term. That is very much interesting. My middle term, I'm going to use this. I use this one with x squared. Okay, then I say now to myself, already I have this part. Okay, negative 2 multiplied by x squared. Negative, I'm going to say negative 2x squared plus what should give me 4x squared. Then I'm going to solve for this. I'm going to say box, it is equal to, when I come to the other side, it is how much? 6x squared. So now, whatever product that should come here, when I multiply it with x, it should give me how much? 6x squared. Actually, when you have done this, you can just take what? Positive 6x. Why? Because when I say x multiplied by 6x, that gives me what? 6x squared. Okay. There is this other method that I like. Maybe I'm not so sure if we're gonna be against time for that method or what. But yeah, I'll be reminded if we have time, so that I come back here. I'll just say NB. For now, this is what we have. Then let's factorize fully. X minus 2, x plus 5, x plus 1. This is us factorizing fully. They just say factorize f of x completely. They did not say find factors, right? So this is our answer thereof. Maybe I might need these answers. I think I'm gonna need these answers later on. So let's just move them there. Okay. Now they say now to us 8.4. It is further given that the coordinates of the turning point are approximately at that one and that one. So we are given, right? Draw a sketch of F and label all intercepts and the turning point. What I like to do is say to my learners, the value of A, which is the gradient here, it is greater than 0. So it means my last shape should be happy. Why? Because if I'm having x squared plus 4x plus 5, do you see this is a quadratic, right? No. Yes, it is a quadratic pattern, which is parabol. The value of A, it is positive here, so I'm going to say it is happy. All right? Yes. Even here on my cubic, when the value of 8 is greater than 0, which is the last shape should be happy. If I know the last shape should be happy, it means I'm expecting a graph of some sort. And I'm told that this coordinate here, let's see, 0.7. 0.7, it is positive. This is negative. So it means here I have the first turning point, which is negative 3.4. And actually, let me enlarge this so that we can see a clearer what I'm trying to explain here. Okay. Okay. Now, I'm saying I'm having my first turning point here. All right. This is my turning point, my local minima, maxima rather. All right. How I'm gonna see this is gonna be the maximum turning point. Why? Because the y value is great. Remember, the maximum, it is the y. This one will be my minimum because it is low. So I'll just put here max and mean. You know the coordinate, right? I see you. I said you check the y value, it is maximum, or you can just check the x value. This is negative, so it means it should be on this side. Then this is positive on that side. Then do this. And now you see, you know that here at -10, your graph cuts. Your graph cuts at -10, something like this. Why? Because it is your y-intercept, right? Then for x-intercept, just do this. Because this is y. Let's say this is 0 somewhere here. Name this your x. Name this your y. Now, now that I have sketched this, I can now be in a position of placing. Remember, I can set this equal to 0, this equal to 0, this equal to 0. So do you all agree with me that my critical values or my x-intercepts, when I equate this to 0, is going to be x, it is equal to 2, x, it is equal to -1, x, it is equal to -5. So you agree with me that here it is the -5 part, this one, right? Then somewhere here it is -1. Somewhere there it is 2. You agree with me? Yes. So now, and here I know it is -10. You do not need to draw this into scale. What's important is the shape and labeling, and labeling the important points thereof. Do you see how easy I have sketched this? Let's take everything. It's fine. I'll take it if needs be. Let's come and put it here. I'm not redrawing this. I am not redrawing this. I have showed you the easier way of drawing. Just draw your shape as it is. Then now I can replace my points here and say this, I was told it is point, yo, 0.7, 0.7, and I don't like how the examiner wrote these numbers now, and 20,8. 8. Then here I think we have -3.4 and what? No. Alright, this is 20,8 actually. That one is -12.6. -12.6. Okay. Alright. Now this is my graph of f. Now let's see. Now that I'm done, I can answer the questions thereof. I can answer the questions related to. I'm gonna use my graph. Now they say, where is the derivative less than 0? Meaning where the gradient is less than 0. It means it is where our function is decreasing or our slope is negative. You can say, remember this is our gradient, right? So you can say where our gradient, which is slope, is negative because it is less than 0, all right? Or where our function it is decreasing. When our function decreases, our gradient is less than 0. Mara, let's just use where our gradient is negative. Gradient here, it is Juan. Can you check? Well, how is my gradient? Positive, right? Yes. It is from this point to that point. Let's use from this point to that point. How is my? You do not need to do a straight line, a precise one. I just want you to see the shape. Is it decreasing or increasing? How is the gradient here? Let me just, from here to there, how is the gradient? You see it is negative, right? And it is from what? It is from when x is an element of what? Between -3.4 and 0.7. It is decreasing, right? And here, how is our slope? Increasing, you see? So it means now the interval that we are looking for, it is from here to here. But please take note of this. Please take note of this. Where our derivative is less than 0, check. I want here, I'm going to say from this point to this point. But check, I am not including those points. I'm not including this point, sorry, this point as well as this point. Why? Because there, at those points, so at this point here, here, my gradient is not decreasing or increasing. It is at stationary. My gradient is 0 there. Here it is not less than 0. It is 0 here. My gradient is 0 there. Hence, I'm not including it there. Okay. Yes, the memo might say you can include no. If you are doing physics, you'll see that when a car is moving, there is no acceleration or there is no velocity. Okay, it is at stationary. So this is our answer thereof. Let me just put it here and erase this. Oh. Okay. Now, use the graph to determine the values of x for which the gradient, I'm translating, the gradient of a tangent will be a minimum. So where will our first derivative be a minimum? So now what I'd advise you to draw is your what? Is your your first derivative. Now what is your first derivative of this graph? Remember, it's gonna be a happy parabola like this. You see here at this point it is a minimum, right? At this point it is a minimum. Now remember I said if your cubic function it ends with a happy face, it means your parabola shape, which is your gradient, will have a happy face, and your straight line will be positive also. You agree? So now I'm saying, where will this graph have a minimum? Check. Man. At this point, it is all y values that are positive or whatever value. But here, it is the most negative. Then it increases. Okay? So at this point, it is the most negative. So it has a minimum value thereof. So if it has a minimum value like that, so it means at this x coordinate of the turning point of our f prime x, then we have a gradient, the gradient of the tangent will be a minimum here, a minimum here. Now, but we know the x coordinate of the turning point, we're gonna get it from the x coordinate of the point of inflection of the graph of f. Okay, remember when I derive f of x, actually let me just explain it this here. When I derive f of x, actually, when I derive f, its coordinate of the turning point become my x-intercept of my graph. Okay? They become my x-intercept of the graph. Then the point of inflection becomes my what? My turning point. Something more or less like this. So I'm saying this is my turning point. This is my x-intercept. So it means my graph is more or less something like that. You see the graph that I drew, or I've drawn. However the English. You see what I mean when I say the x coordinate of the point of inflection of the cubic function is the what? The x coordinate of the turning point. Okay, so now how can I get the x coordinate of the turning point? Because it is the one that I need of the point of inflection rather. So I know for the point of inflection, how do I get that? I do what I say, the second derivative should equal to 0. Or I can say it is a midpoint between these 2 points. The first one I can say, or the second one, use midpoint. Let me see how much time I have. Okay. Then now the second derivative of this function, let's see. The first derivative is going to be 3x squared plus 4x minus 7. The second derivative is going to be 6x plus 4. I want this. It should equal to 0, not like this. It will equal to 0. Therefore, x is going to be negative 2 divided by 3. And do you agree with me? Point of inflection, it is more or less between these points. If it is between these two turning points, it is somewhere maybe here. Point of inflection, right? So this is where our tangent will have a minimum. So we'll say x, it is equal to negative 2 divided by 3. Or you can use this midpoint and say if it is the midpoint, then your x should be equal to this value plus this value divided by 2. Let's see if it gives us the correct answer now. It should. Negative 3.4 plus this, it is negative 2 point, negative 2.4, 2.7, I think, divided by 2. Then negative 2.7 divided by 2, it is negative 1 point. This is going to be something like 3.5. Something of that. Yo, this English is running away. Let me grab my calculator. Okay. Negative 3 divided by negative 3.4 plus 0.7 divided by 2. I get negative 1.32. Then here I get x, it is equal to, this is negative 0.67 most. Let's see. Point of inflection, this plus this divided by 2, right? Maybe I derived wrong. 6x plus 4. Yes. Oh, okay. Let's see. Okay. First derive, this is 3x squared, probably derived wrong, plus 8x minus 7. Then this is 6x plus 8 is equal to 0. Let's see. X, it is equal to negative 4 divided by 3. Negative 4 divided by 3, it is negative 1 comma on 10, it is 3. Then it remains a remainder of 1, then 3 recurring. Then here how much do I get? Negative 3. But here let's just fix this. Okay, I don't want to waste any further time. All right, yes. So just take the second derivative, it will give you the most correct answer. Let's see if I have enough time. I need to explain this thoroughly. Okay, I think I have. Now wait, let's go directly to my graph. Now they say where is f prime x multiplied by second derivative of this less than 0. Now I need you to draw this graph, the graph of this and the graph of that. That's the only way I'm going to teach you this. So we said this is going to be the coordinates of the turning point of the x-intercepts of the parabola, because when I derive that, then I saw that when I derive this, somewhere here, this point, right, point of inflection, it is somewhere here. So my graph will be more or less something like something of that of some sort. Okay, more or less something like that. Okay, then how is my graph of a second derivative, which is my straight line? This point here is going to be my point of my x-intercept somewhere here, or maybe yes, then it's going to be an increasing part like this. Yes. So this is my second derivative. This is my f prime. Now they want where when I multiply these two, sorry, when I multiply this by this, it should be less than 0. It means I want where this is negative positive or positive negative. Let's see. Let's see for the graph. This is for the graph of second derivative. This is negative, 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 positive, 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 positive. Then let's look at my graph here. We are looking at the y values: positive, 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 negative, 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 positive, 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 positive. So we want where this one is negative, this one is positive. So negative f prime is negative on this portion. All right, but at the same time, where is our f prime positive? It is from here to there. So I'm gonna take the point where they intersect, actually where it is both true. So you agree with me that from this portion here, when I take this part only, that condition is true. This one is positive, the other one is negative, right? So I'm gonna say it is between what's this coordinate here? Let's see, it's set to be negative. Actually, at oh, even here, from this point, actually. Okay, let me say I'm gonna explain this on the new video. I want you to see it clearly. Okay, allow me to explain this on a new video.